Good morning, everyone. This is Henry from ASTEM Tutoring, once again attempting to serve as your wise old sensei. In a previous video, we talked about using Desmos to find a regression line, a predicted equation for a given set of data points. Today, we'll revisit the topic and explain how the math behind that works. What's the magic behind the machine? So first of all, let's look at a Desmos graph that I have here. So this is a simple set of data points, and I used the linear regression tool in Desmos to find a regression line. So the line that predicts other data points in this set would be y equals 1.897771x plus 3.14238. That would predict a new value of y given a different x value. For example, if we wanted to find y when x is 6, we could plug it into this equation and find a predicted value of y. Now, the question becomes, how does Desmos take these data points and find this number, the y-intercept, and this number, the slope of the regression line? So let's go ahead over to a whiteboard here. If we write the regression line equation as this, the predicted value of y equals beta 1 predictor of x plus beta 0 predicted, where beta 0 is the y-intercept and beta 1 is the slope of the regression line that would predict a new value of y given an input value of x. So given data points, for example, we have x1, y1, x2, y2, and so on. And all these could be considered a subset of xi, comma, yi. Right. So how do we do that? So this represents all of these data points. The formula for beta 1 hat is simply the summation of xi minus the mean of x times yi minus the mean of y, all divided by the summation of the square of xi minus the mean of x. So basically, for every data point, you take that data point minus its mean for x and y. That's your numerator. The denominator is for every data point, you take that value of x minus the mean of x, square it. The summation of that is the denominator. And once you run this, that will give you beta 1, the slope. Once you have that, beta 0 hat is much easier. It is simply the mean of y minus beta 1 hat times the mean of x. So how does this work? Well, let's plug in these numbers into an Excel spreadsheet, or a LibreOffice spreadsheet as it were. So here I have the same data points, x and y, right? This data matches this data in this chart that I put into Desmos. I simply typed it into a spreadsheet. I used the average function in LibreOffice Calc to find the mean of x and the mean of y. So for every data point, we subtract that data point minus its corresponding mean. So we have x minus mean of x. So this would be this minus 2.5. So, sorry, 1 second. This equals this cell minus 2.5, the mean of x. And we can copy this and paste it all the way down. Here we have y minus the mean of y that would equal first cell of y minus the mean of y, 7.887. And again, we can copy and paste this all the way down. Now, if we want to find the square of x minus, and I'll just leave it blank, well, the x minus the mean of x, then this equals the square of this cell. And we can do that all the way down. So now we can multiply columns D and E to find what we will sum for our numerator. So we'll label this D star E. This equals cell from column D times cell from column E. And again, we copy and paste this all the way down. So we find the summation. This equals the sum of squared difference of x from its mean. This equals the summation of column G. The difference from xi to its mean times the difference of yi to its mean. Then when we divide this, so slope should be column cell G11 divided by cell F11. This divided by this. 1.89771, which agrees with Desmos, 1.89771 for the slope of the regression line. Now, to find the intercept, we take the mean of y minus the slope times the mean of x. 3.14238, which agrees with Desmos, 3.14238. So this spreadsheet demonstrates the mechanics behind what the machine is doing when you use Desmos to find a regression line for a given set of data points. Now, we could have done this by hand, but that would have been slow, tedious, and painful. So to make it a little bit less slow, tedious, and painful, I cheated a little bit and used a spreadsheet. And I simply put in the formulas as discussed on the whiteboard. This concludes today's lesson. This has been a discussion of how to find the parameters for a regression line to predict new values of a y variable given a new x variable from a given set of x, y data. If you'd like to learn more, I'm available for hire as a private tutor. The first 1-hour lesson is free. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service to help you succeed. And as a thank you for watching all the way to the end of today's lesson, when you contact me, please mention the code FREEBOOK. And at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is also available for purchase on the Barnes & Noble website. I wrote this in an effort to help students, and particularly high school students and college students, to succeed in school, work, and in life. Thanks for watching. Have a good day.